Most people think of the speed of light as just a number, 299,792,458 meters per second. Fast, incredibly fast, the fastest thing we know. And for most people, that's where the story ends. The speed of light is the cosmic speed limit. Einstein said so. Physics textbooks say so. End of discussion. But that's not really an answer. That's just repeating the rule without understanding the reason. When you actually ask why nothing can go faster than light, what is really stopping it, you uncover something far stranger and far more beautiful than a simple speed limit. You discover that the speed of light is not just about light at all. It is woven into the very structure of the universe. It is part of how space and time themselves are built. To see why, we need to start with something simple, something familiar. Things fall. Drop an object, and it falls to the ground. Galileo studied this carefully and found that near the Earth's surface, objects fall at a predictable rate. In the first second, they fall about 16 feet. This seems ordinary, almost boring, but this simple fact is one of the deepest clues we have about how the universe works. Now think about the moon. The moon is not falling to Earth. It stays up there, circling us again and again, but why? Gravity is pulling on it, just as gravity pulls on everything else. If the moon were just sitting still in space, it would fall straight down and crash into Earth. The only reason it doesn't is because it is moving sideways. As gravity pulls it inward, its sideways motion carries it forward. It falls toward Earth but keeps missing. That continuous falling, combined with sideways motion, is what an orbit really is. An orbit is not balance, it is perpetual falling. Isaac Newton realized something extraordinary here. The same force that makes an apple fall might be the force that controls the motion of the moon and the planets. At the time, this idea was revolutionary. People believed that the heavens followed different rules than the Earth. Newton suspected otherwise. He noticed that the moon is about 60 times farther from the center of the Earth than we are standing on its surface. He proposed that gravity gets weaker with distance, following an inverse square law. If you double the distance, gravity becomes 4 times weaker. If you increase the distance 60 times, gravity becomes 60 squared times weaker, about 3,600 times weaker. Now comes the test. On Earth, objects fall 16 feet in 1 second. If gravity at the moon's distance is 3,600 times weaker, then the moon should fall toward Earth by 16 feet, divided by 3,600 in 1 second. That works out to roughly 1/12 of an inch per second squared. Newton calculated how much the moon actually falls inward during its orbit. The numbers matched perfectly. This was not philosophy. It was a prediction that came true. In a single stroke, Newton connected falling objects on Earth with the motion of the moon in the sky. Two phenomena that seemed completely unrelated were unified by one law. From this law, even more followed. Newton showed that if gravity follows an inverse square law, planetary orbits must be ellipses. Johannes Kepler had already observed this, but Newton explained why. He also explained the tides. If the moon pulls on Earth, why are there 2 high tides each day instead of 1? The answer lies in differences. The water on the side of Earth closest to the moon is pulled more strongly than the Earth itself. The water on the far side is pulled less strongly than the Earth. These differences create 2 bulges and therefore 2 tides. The roundness of planets, the flattening caused by rotation, even the behavior of oceans all fell into place. As measurements became more precise, scientists tested Newton's law again and again. Eventually, something strange appeared. The moons of Jupiter did not move exactly as predicted. Sometimes they were early by about 8 minutes. Sometimes they were late by about 8 minutes. That was a huge discrepancy. But then Ole Römer noticed a pattern. The moons were early when Jupiter was closer to Earth and late when Jupiter was farther away. He realized that light itself takes time to travel. What we see is not what is happening now, but what happened minutes ago. When this delay was accounted for, the discrepancy vanished. Without measuring light directly, scientists had discovered its finite speed by trusting the law of gravity. Once the speed of light was known, something deeply unsettling emerged. Light always travels at the same speed, always. No matter who measures it, no matter how fast they are moving. If you stand still and shine a flashlight, you measure the speed of light. If you ride a train moving at half the speed of light and shine the flashlight forward, you measure the same speed. Go faster, still the same. Go almost as fast as light itself, still the same. Light speed does not add. This completely breaks everyday intuition. Speeds are supposed to combine, but light refuses to cooperate. Einstein realized the only possible explanation. Space and time themselves must change. Time slows down for moving objects. Space contracts in the direction of motion. These are not illusions. They are not measurement errors. They are real physical effects, and they happen by exactly the right amount to keep the speed of light the same for everyone. The universe bends space and time to protect this constant. As you try to accelerate an object with mass, something even stranger happens. The faster it goes, the harder it becomes to accelerate further. Its inertia increases. As you approach the speed of light, the energy required to go faster grows without bound. To actually reach the speed of light would require infinite energy, which is impossible. That is why nothing with mass can ever reach that speed. Photons can because they have no mass. They must move at that speed. This is not a technological limit. It is built into the structure of space-time itself. You're always moving through space-time at a constant rate. If you are standing still in space, all of your motion is through time, 1 second per second. When you start moving through space, some of that motion is diverted away from time. Time slows down. The faster you move through space, the slower you move through time. At the speed of light, all motion is through space, leaving none for time. That is why light experiences no passage of time. From a photon's perspective, emission and absorption happen in the same instant. This has been tested endlessly. Particle accelerators confirm it. GPS satellites depend on it. Muons created in the upper atmosphere reach the ground only because time slows down for them as they move near light speed. If relativity were wrong, modern technology would fail instantly. So why is the speed of light the limit? Because space-time has a maximum rate at which cause and effect can propagate. That rate is the speed of light. It is not imposed on the universe. It emerges from how the universe is structured. Even if light did not exist, the limit would still be there. Light simply reveals it. The speed of light is not just a number. It is the key that unlocks the nature of space and time. It shows us that the universe is stranger and more beautiful than common sense allows, and that through careful observation, logic, and imagination, we can actually understand it. The fastest thing we know. Fine. But why is it the limit? Why can't you go faster? What stops you? Most people have never really thought about this. They just accept it.